This is Advanced Math Set 78, the hyperbola. Okay, so first we'll review. This is the equation of an ellipse. This is an ellipse with center at the origin, and the standard form of the equation is right here. X squared over a squared plus y squared over b squared equals 1. So we can see A is half the length of the major axis. This would be your major axis here. And then B is half the length of your minor axis. And then your minor axis would be this one here. It's shorter. All right. So now we have the standard form of the equation of a hyperbola. This is what this lesson is about. This is centered at the origin, and the foci are on the x-axis. So your focus here is going to be F1 and F2. Now, the equation of a hyperbola is very similar to the equation of ellipse. They are both equal to 1. They both have an x squared, y squared, a squared, and b squared. The main difference is that there is the minus sign. The minus sign identifies it as a hyperbola, and then a squared and b squared will always be in the same order. And then what changes is the x squared and the y squared. And we'll see what that means in just a minute. So if your x squared comes first, it crosses the x-axis. So you can see where that parabola or the hyperbola crosses the x-axis. That is because the x comes first, and it is kind of like a horizontal shape. If we're looking this way, this hyperbola is over the y-axis, and you can see that it crosses the y-axis at these points as well. You can see the shape is kind of like an hourglass shape, and y squared is coming first in this case. So let's do an example. Sketch the hyperbola x squared over 9 minus y squared over 4 equals 1. So first of all, it's equal to 1. Second, we see that minus sign, and so we need to identify a and b. Remember, a always comes first, so a squared equals 9. So a is equal to plus or minus the square root of 9, or this plus or minus 3. b squared is equal to 4. B is plus or minus the square root of 4, or plus or minus 2. So now we'll graph it. Because x squared comes first with the a, then I know that I'm going to put the red on the x's, on the x-axis. So you've got plus or minus 3 there. And then the y, the blue, is going to go on the y-axis, plus or minus 2. From there, I've got my points. I'm going to make a rectangle, a little rectangle like this. And then I'm going to put 2 lines through the diagonals of the rectangle. Those are called asymptotes. So asymptotes go through the diagonals of the rectangle that I made with those a's and b's. Now we need to find the equation of the asymptotes. So you can see that if we start at the origin, we can go up 2 over 3 to get a slope of 2/3, y-intercept of 0, so y equals 2/3 x. The other line, you're going down 2 over 3, so it's going to be y equals negative 2/3 x. And then finally, we graph the hyperbola. The graph always goes through the vertices that we already identified with the red and the blue dots. And because x comes first, it's crossing the x-axis. So it is a horizontal hyperbola. Let's do another example. Sketch the hyperbola y squared over 4 minus x squared over 25 equals 1, and find the equations of the asymptotes. So I know a squared always comes first. A squared equals 4. A equals plus or minus the square root of 4, so a equals plus or minus 2. B is going to be b squared equals 25. so b is plus or minus 25. So b is plus or minus 5. Now we'll graph it. A is plus or minus 2, and notice that this time the A is with the Y, so I'm going on the Y axis. Plus 2, minus 2. Now I'll put the B on the X axis, plus 5, minus 5, draw my little rectangle. Then I'm going to draw asymptotes from the corners of the rectangle and find the slope from the origin. So I'm going to go up 2 over 5 to get an asymptote of y equals 2/5 x. From the same point, from the origin, if I go down 2 over 5, I will get the second line, y equals negative 2/5 x. And then the last thing to do is to graph the hyperbola itself. I start at the vertex, the red vertex, and then I go close to the asymptotes. And so I'm going to, because it starts at y squared, it's going through the y-axis. And then I get as close to the asymptotes as possible. I do not go inside the rectangle. I stay on that vertex. And then we also do it on the bottom. Okay, so given the hyperbola 4x squared minus 9x squared minus 36 equals 0, write the equation in standard form and find the vertices and the equations of the asymptotes. Graph the hyperbola. So we write the equation. We're going to solve it. We need it equal to 1. So to get it equal to 1, we're going to divide everything by 36. When I divide everything by 36, I get y squared over 9 minus x squared over 4 equals 1. Now I identify a and b. Remember, a always comes first. A squared is 9. A is plus or minus the square root of 9, so that is plus or minus 3. B, that should be a b. B squared equals 4. B equals plus or minus the square root of 4, and b equals plus or minus 2. Okay, now we're going to go graph it. A is plus or minus 3, and remember y comes first, so I'm going onto the y-axis at 3 and negative 3. Then I'm going to go to the x-axis, and I'm going to graph plus or minus 2, draw the rectangle, and then draw the lines that go through the corners of the rectangle. Now I'm going to find the equation of the lines starting at the origin. I go up 3 over 2 to get y equals 3/2 x. Going back to the origin, you go down 3 over 2 to get negative 3/2 x. And then I graph my vertices. My vertices are 2, 0, which are the blue dots, negative 2, 0, and then 0, 3, and 0, negative 3. And then finally, what I'm going to do is graph the hyperbola itself. So to graph the hyperbola itself, notice that it is y squared first, so I'm going to go through the y-axis. So going through the y-axis, you can see I graph it up there on the top, graph it on the bottom, and then so it says I need the equation in standard form, that's highlighted in pink. I need the equation of the vertices, or the location of the vertices, which is highlighted in green, and then the equations of the asymptotes, which are highlighted in blue.